Good morning everyone. I am Tanushree Dalai from Civil Engineering branch, and today I am going to teach you your Theory 2 paper which name is Structural Design 2. So in the last class we discussed about the strength calculation of tension member so that we solved a problem based on plate section and flats. And today we will discuss the strength calculation of an angle section. So let's get started. So here is your question, which is a single unequal angle ISA, which is Indian Standard Unequal Angle Section. The dimension is 100 into 75 into 8 mm. That is, the 175 is the width of or the length of the leg of angle section, and 8 mm is the thickness of the angle section, which is connected by longer leg to a 12 mm gusset plate. It ends with 4 numbers of 20 mm dia field bearing bolts of property class 4.6 in one line as shown in the figure. Determine the design tensile strength of the angle section. So now, what are the data given here? First of all, the dimension of the unequal angle section is given, and the longer leg of the angle section, that is the 100 mm, is connected to a gusset plate, and the thickness of the gusset plate is 12 mm. And the angle section is connected to the gusset plate by 4 numbers of 20 mm dia bolt. So now, first of all, we will write the data given. So here we have to assume the steel is of grade Fe410. For Fe410, the yield stress is 250 MPa and ultimate strength is 410 MPa. And gamma m0 is 1.1, gamma ml is equal to 1.25. Next is for 20 mm dia bolt, the bolt hole diameter is 22 mm and the partial safety factor for the bolt, which is gamma mb, equal to 1.25, and the nominal diameter of the bolt is 245 mm square. So here is the diagram of the angle section which is connected to the gusset plate. So from this to this is the longer leg of the angle section, which is 100 mm, and this portion is the other leg of the angle section, and here the thickness we can see, and the edge distance of the angle section is given as 40 mm and the pitch distance of the bolt is given as 50 mm. So now, first of all, we need to calculate the first strength calculation, which is strength of the angle section against yielding. So for the yielding strength, the formula is TDG equal to AG into Fy divided by gamma m0. So, for the ISA 100 into 75 into 8, the cross section area is 13.36 mm square, which you can find out from the steel table in table number 2. Your each angle section is subdivided into 4 types or 3 types as per the thickness. So you can see in the steel table, the table number 2 is for unequal angle section. So how you can recognize the equal and unequal angle section? So you can analyze the angle section whether it is equal or unequal from this first 2 value, which is the length of the legs. So if the legs are equal angle type, then the first 2 value is equal. That means if we take an example of equal angle section like 50 into 50 into 6, that means the 2 legs are of 50 mm length. But here the 2 legs are of different kinds of length. One is your longer leg and another is your shorter leg, by which you can recognize that this type of angle section is unequal angle section. So in the steel table, you can analyze the cross section area of the unequal angle section from the table number 2. So according to the ISA 100 into 75, it is subdivided into 4 types of thickness. One is 6 mm, second one is 8 mm, third one is 10 mm, and fourth one is 12 mm. So we just need the cross section area for the 8 mm thickness. So you can see the cross section area column, in which you can find out the cross section area of the angle section is given as 13.36 centimeter square. So just put this value here and convert it into centimeter square to mm square. So 13.36 centimeter square is equal to 1336 mm square. So now we can put the AG value here and calculate the TDG. So AG into Fy divided by gamma m0 equal to 1336 into 250 divided by 1.1, which equal to 303.64 kilonewton. So the strength of the angle section against yielding is equal to 303.64 kilonewton. So now comes to the second strength calculation, which is strength of the angle section against rupture. So we know that in case of rupture, the calculation of plate section is different and calculation of angle section is different. So for calculation of angle section, first of all we need to calculate the net area of the connected leg. Connected leg means the leg which connected to the gusset by the help of bolting is known as connected leg. So first of all we need to calculate the area of this portion. So the formula is length of the connected leg minus diameter of the bolt minus thickness of the connected leg divided by 2 multiplied by thickness of the connected leg. So by putting this value as 100 minus 20 minus 8 by 2 whole multiplied by 8, we got the value of net area of the connected leg, which is ANC, as 608 mm square. So now we need to calculate the gross section area of the outstanding leg, which is denoted as AGO. So AGO equal to length of the shorter leg or outstanding leg minus thickness of the outstanding leg divided by 2 whole multiplied by thickness of the outstanding leg. Outstanding leg means the leg which is not connected to the gusset. That means this leg. Okay. So by putting the value, which is 75 minus 8 by 2 into 8, by which we got the value of AGO as 568 mm square. After that, we need to calculate a factor which is known as beta, which formula is 1.4 minus 0.076 multiplied by omega by t into Fy by Fu into Bs by Lc. So first of all, we need to know the value of omega, Bs and Lc. So we know that the omega is the width of the outstanding leg, which is 75. That means this portion, which is the shorter leg of the angle section. So it is 75 mm. So omega equal to 75 mm. And after that, for the calculation of Bs, we need to calculate omega I, which is the value of the center of the bolt to the junction of the angle section. That means from here to this point. So you can see from this figure, from the center of the junction, the distance is 60 mm. So omega I equal to 60 mm. So now put the value of omega and omega I and thickness in the Bs formula, which is omega plus omega I minus t. So omega is 75 plus omega I is 60 minus t is your 80. So by calculating this, we got the Bs value as 127 mm. So now we calculate Lc value, which is the length of connection. That means from the first center of the bolt to the last center of the bolt. That means from here to here. So from here to here, the value of the pitch is 50, again 50 and again 50. So the total length of the connection is 50 into 3, which is 150 mm. So by putting all this value, we can calculate the beta as 1.032, and it should be greater than 0.7 and less than Fu gamma m0 divided by Fy gamma ml. So today this much. We will discuss next thing in the next class. Thank you.